Okay, hello Integrated Science, this is Mr. B, and we are continuing on with section 2 of the Earth-Moon system. Again, kind of got last section there, or last part of this section, I'm sorry, it was about some structures that are found on the moon, how the moon was formed, and now we're just going to talk about, to start this video, one of the most physical, or one of the most visible features that we have of the moon are what are called phases of the moon, which is something we've all seen, but I'm going to actually explain why that happens. So the moon's phases are caused by changes in the relative positions of the moon, sun, and earth as the moon revolves around the earth. So the moon doesn't produce its own light. It reflects light from the sun, which we kind of mentioned that no other body in our solar system produces its own light. It's all from the sun. When we look at the moon, sometimes it appears full and bright. Sometimes it only appears as a tiny little sliver. All of those different shapes of the moon visible from Earth are called phases of the moon. So the reason why, again, we see all those is because they're on different phases. So sunlight will illuminate half of the moon. The phase of the moon depends on how much of the sunlit portion of the moon is actually facing the Earth. So a full moon will occur when the moon is on the opposite side of the Earth from the sun. Again, they kind of are going to show some pictures, but again, sun all the way, if the sun's all the way over here, the moon's all the way over here, that means all of the light will be directly reflected off of there, and so therefore we will see a full moon. Then kind of the opposite of a full moon is what is called a new moon, and a new moon occurs when the moon is directly between the sun and the earth. And the new moon cannot be seen from Earth because the sunlit side of the moon is facing away from us. So sun is up here, moon is right here, which again we can maybe draw some diagrams in class to explain this a little bit better. Sun up here, moon up here, Earth right here. Again, we're not going to be able to see the side that's receiving the sun's rays. Okay, if I don't know if I have a little drawing feature on here, I need to probably mess around with that. I could probably draw you some helpful little pictures there, and we can talk about that more in class as well. So we're going to talk about this diagram more. Again, I might have you create your own version of this diagram here. But this is just kind of two different views of the phases of the moon are shown in this diagram. Again, up here, kind of some of the phases of the moon, kind of depending on its location around Earth, and then over here from the sun. And down here we have, again, some different ones as well. So, like I said, I'm not going to have you, don't worry about writing this down yet. We'll talk about this more in class, probably have you do some work on that one as well. So just kind of some more about the phases. It takes about 29.5 days for the moon to complete a full cycle of phases. So this period is known as a lunar month. So again, all these different phases here. Again, new moon to waxing, crescent, first quarter, and then waxing gibbous, full moon, waning, third quarter, yada, yada, yada. Again, it takes about, again, we'll talk about those more. It takes about 29.5 days for it to complete those full cycle of phases, known as a lunar month. The same side of the moon always faces Earth, and that's because the moon makes one full rotation around its axis while making one full revolution around Earth. So this is probably something that you would need to write down and get some things we can explore more in class as well. So kind of go along with the phases of the moon, something that actually happened just about recently, as our, again, this recorded in 2018, in case we're watching this at a later date, is a difference between a solar eclipse and a lunar eclipse. So a solar eclipse occurs when the moon casts a shadow on a portion of Earth's surface, and then a lunar eclipse occurs when Earth casts a shadow on the moon. So there is a difference. Again, we'll see, I think they actually do have some pictures of this one, so knowing the difference between a solar and a lunar eclipse is important. But in general, what an eclipse is defined as is when the shadow of one body in space, such as a planet or moon, falls on top of another. For an eclipse to occur on Earth, the sun, the moon, and the earth must all lie along a straight line. So again, for us to observe an eclipse, the earth, the sun, and the moon all have to be in a straight line because therefore a shadow will fall onto the earth. Again, eclipses do not occur every month because the plane of the moon's orbit is tilted about 5 degrees with respect to the ecliptic. So that means, again, if everything was in a perfect line, you would think by each phase of the moon that we should get an eclipse every month. But because that little bit of the tilt there kind of results in eclipses being a little bit more rare than that, actually. It will only occur when the moon crosses Earth's ecliptic plane, so that's, again, its orbit that it falls along the sun at the time of the new moon or a full moon. So they might pass each other's plane when it's maybe in a waxing crescent or something like that, but that's not going to give us an eclipse. The eclipse will only occur possibility with a new moon or a full moon. During a new moon, when the moon is between the sun and the earth may pass through the shadow of the moon. The small cone-shaped umbra is how you say that the umbra is the darkest part of the moon's shadow. In the umbra, the moon completely blocks out sunlight. So, and if this were to occur, there would be a very few people in a narrow path across Earth's surface that would see what's called a total solar eclipse. So, again, this happened again in some areas. Again, when we had our most recent eclipse, but that will only occur again when the Earth passes through the shadow of the moon. Again, it'll block out the sun. Again, we had our special glasses out to look at it if you went out there to see. But to see the umbra, only a very few people saw that in that total solar eclipse. But surrounding that was called the penumbra, which is the region of the shadow that is less dark. So more people were able to see a partial solar eclipse, again, depending on your location. But again, those are excuse me, two important words there, and again, we're going to work more with these vocabulary words because you'll notice there is a lot of vocabulary words within this section. So people within the penumbra see only a partial solar eclipse. During full moons, when Earth is between the sun and moon, the moon may pass through Earth's shadow. Earth's shadow also has an umbra and a penumbra. And if the moon passes completely into Earth's umbra, you will see a total lunar eclipse. And if the moon passes partially through it, you will see a partial lunar eclipse. So a lunar eclipse occurs when the moon passes through Earth's shadow, and a solar eclipse occurs when the sun comes between, or when the moon comes between Earth and sun, and then the moon's shadow is cast upon the Earth as well. Again, I know that might sound confusing, but we will talk more about those. Again, here's those pictures I was telling you about. So again, solar eclipse, we have our light from the sun. The moon is blocking the sun, and therefore the shadow called the umbra, and then the penumbra is cast onto Earth. Then the lunar eclipse, again, we have our sunlight here. Now the sunlight is between Earth and the moon, and the shadow from the Earth is then therefore cast upon the moon. So again, this is kind of what a solar eclipse will look like. Again, hopefully not looking at that without your sunglasses that we had out there when that happened, and then this is what a lunar eclipse would look like. So again, we're going to work with those more in class, but again, just trying to know the basic difference between those two will probably be important for your quiz. And then our last kind of structure or kind of important thing with the moon that we're going to talk about are tides. So tides are regular rise and fall of ocean waters, and they are caused mainly by differences in the moon's gravitational pull here on Earth. So the gravitational force of the moon pulls more strongly on the side of Earth that faces it and less strongly on the side that is away from it. So this difference causes the entire Earth to kind of be actually stretched out. So the effect of the moon's gravity on the ocean is much greater than that on the solid Earth. So the moon is actually exerting a gravitational pull here on Earth. Again, it's not strong enough to like pull up rocks or anything like that or any harder material. However, it does have an effect on the oceans. So that is why we have those high and low tides, and that's why the water is more affected by this pull. The gravitational pull of the moon causes the oceans to bulge at locations closest and farthest from it. As Earth rotates on its axis, the high tides occurs when an area moves through either of those two bulges. And most coastal areas experience 2 high tides and 2 low tides each day. So, again, depending on where the moon is at, again, it's going to pull stronger in that area. Again, if it's pulling stronger where you're closer, you're going to kind of have a higher tide. And again, if it's kind of farther away from you when it's pulling, that's when you're going to have the lower tide because there's probably going to be a high tide somewhere else. The sun also has a gravitational effect on our oceans, but its tidal effects are only about half of those of the moon. So the moon, again, is kind of our big kind of driving force behind those tides there. During a new or full moon, the sun, moon, and Earth are all in a straight line. This produces what's called a spring tide, where the change between daily high tides and low tides is the greatest. So again, kind of associated, again, kind of with those eclipses, kind of similar type thing going on with the pull of the tides as well. When the moon is at its first or third quarter, the moon and the sun are pulling the Earth at right angles. This is a result in what's called a neap tide, where there is the least change between daily high and low tides. So depending on where the position of the moon is, sometimes we have really strong tides, sometimes we have really low. again, because its gravitational force is kind of difference between kind of what's being pulled there. And again, this is just kind of another, again, kind of visual representation. Again, the spring tides, a pull of the moon and sun add together, so that's kind of why they are so much stronger. And then during neap tides, the moon and sun pull Earth and its oceans at right angles, so they're not really working together, and so that's why it is a little bit lower. So this picture, I think, will be a little bit more of a help, but again, we'll talk about that more in class as well. So that's it for this video. Let me know if you have any questions.